After going through this video, you will be able to explain and apply the following properties associated with the flex box: flex basis, flex grow, and flex shrink. Let's continue our discussion on flex box properties. The next property which we will discuss is flex basis, which is applied to flex items. So far we have covered two properties that are applicable only to the parent element and not to the child elements, that is flex items. Flex basis is used to define the size of items along the main axis. This means, in case of flex direction property value as row and row reverse, it defines the item's width. And in case of column and column reverse value, it defines the item's height. But let us consider the flex direction as row for now for easy understanding. The default value is auto and it can be defined for any length value. In case we define any length value for flex basis, it will override the width property even if it is defined explicitly in the code. If the flex basis property value and width property value are both defined as auto, then the width mentioned in the width property is considered. And if even the width property is not defined, then it takes the default width value auto, which means the item would take the minimal space required just to fit in the content. Let's simplify this with the help of an example. Here we have explicitly given a width of 100 pixels to all the child div elements. But for the first div with class 1, we have set the flex basis as 50 pixels. This overrides the width property and sets the width of this element as 50 pixels. For the second div with class equal to 2, we have set the flex basis as auto, which is its default value. Flex basis auto means the width property of the element will be considered, which again sets the width of this element as 100 pixels. And for the third div with class equal to 3, we have set the flex basis as 200 pixels. This also overrides the width property and sets the width of this element as 200 pixels. Next, we have flex grow and flex shrink properties. But before that, we need to understand what is available space and deficit space. Suppose we have a container whose width is 500 pixels and inside this container, we want to place 3 items of 100 pixels each. This means that the total space occupied by the items will be 300 pixels and we are left with empty space of 200 pixels. This empty or extra space is called as available space. Now let's say instead of 100 pixel items, we want to place 3 items of 200 pixel each. This makes the total element width as 600 pixel and the width of the container is 500 pixel. This means we have a shortage of 100 pixel space, which is called deficit space. So, I hope the concept of available and deficit space is clear. Let us move to flex grow property now. Flex grow property is applied to flex items. It is only applicable if the flex container has available space after placing all the flex items. Otherwise, it has no significance and is ignored. Its default value is 0. It causes an item to stretch beyond its specified width in proportion to other flex items as per the flex grow values. Let's simplify this with the help of this code example. Here, the container has a width of 500 pixels. The box sizing is set to border box for all elements and that the container has a border of 2 pixels on each side. Therefore, the space the container has inside the borders for its children is 500 minus 4, that is 496 pixels. Here, we have specified the flex basis for all the 3 items to be 100 pixels. This means that all the items will take a combined width of 300 pixels. This leaves us with 196 pixels of available space inside the container. Now, we have also specified the flex grow property for each item. For the first item with class equal to 1, we have set the flex grow as 0, which is also its default value. It means the item is not allowed to stretch beyond its specified width even if there is any available space. But for the second and third items, we have set the flex basis of both the items as 1. It means both these items would stretch beyond their specified width to take up the entire available space in a ratio of 1 to 1. This means the available space of 196 pixels will be distributed to both these items in a ratio of 1:1, that is equally. So, their new width will be 100 pixel plus 196 pixel by 2 equal to 198 pixel each. Hence, the first item will have a width of 100 pixel and the second and third items will be of 198 pixels each. We can also verify the width of the items using the inspect element. We will right click on the item whose width we want to verify like this. Here, we can see that the width of the first item is 100 pixel and the width of the second and third items are 198 pixel each. Now, let's say we have updated the flex grow value as 1, 2 and 1 for the first, second and third item respectively. What would be the width of the first, second and third items now? You may pause the video and take your time to do the calculations. Let's see if your answer matches with the answer that we have. The width of the first and third item is 149 pixel and the width of the second item is 198 pixel. Now let's make it more interesting. What if for the first two items we have flex grow value as 0 and for the third item as 1? What will be the width of items in this case? I suggest that you solve this question because there will be a similar question in the quiz also. Now let's discuss the next property, flex shrink. Similar to flex grow, this property is also applied only to flex items. It is only applicable if the container has deficit space. Its default value is 1. It causes an item to shrink in proportion to other flex items as per their flex shrink values. Please note that the minimum size of the item will be taken into consideration while shrinking an element. That is, an item's width will never be reduced to smaller than the size of its content. Sounds complicated, right? Don't worry, let's understand using this example. Here, the value of flex basis is defined in such a way that the combined width of all the items is more than that of the container. The container has a width of 500 pixel with the width of 496 pixel of space for its children. The child items are given a width of 200 pixel each. This means the total space required to place these items is 600 pixel. This creates a deficit of 600 minus 496 pixels, that is equal to 104 pixel. But if we look at the output, we can see that all the items fit in well inside the container. This is because of the default value of flex shrink property as 1. All the three items here have the flex shrink value as 1. It means that all the three items would shrink to compensate for the entire deficit space, that is in a ratio of 1:1:1. This means the deficit space of 104 pixel will be taken away from these three items equally. So their width will be 200 pixel minus 104 divided by 3, that is equal to 165.33 pixels. Let's change the default flex shrink value to 0 for all the items. In the output, we can see that the items overflow from the container. This means the default behavior of items is to shrink and not to overflow. So to prevent the items from shrinking, we need to explicitly set the flex shrink property value as 0. Now let's say we have updated the flex shrink values as 1, 1 and 2 for the first, second and third items respectively. What would be the width of the first, second and third items? You may pause the video and take your time to do the calculations. The width of the first and the second item will be 200 pixel minus 104 pixel divided by 4, that is 174 pixel. And the width of the third item will be 200 pixel minus 104 pixel divided by 2, that is equal to 148 pixel. Now you may ask, why are we dividing by 4 for the first and second element and by 2 for the third element? Well, this is because the width is distributed between the first, second and third item in the ratio of 1:1:2 respectively. This makes the share of the first and second item as 1 divided by 1 plus 1 plus 2, that is equal to 1 by 4. And the share of the third item as 2 divided by 4, that makes 1 by 2. With this, we have come to the end of this video. In the next video, we will continue to explore more properties related to Flexbox.